What is NetLogo AR? NetLogo AR is an authoring toolkit that could transform agent-based computational models into augmented reality experiences. The augmented reality experiences could then interact with complex real-world surroundings in many ways. Before we move into the AR part, what are agent-based computational models? Let's start with the classical ants model in NetLogo. NetLogo is the most widely used computational platform for agent-based modeling. The model simulates an ant colony. Each ant in this model follows the same set of simple computational rules. First, the ant randomly moves around the world. Once it finds a food pile, the ant takes one piece of food and starts heading toward the smell of its nest. The ant will also leave a trail of chemicals so that other ants could follow. The chemicals will disseminate and disappear with time. While a single ant might not behave very intelligently, a group of ants could easily take piles of food back home in a short period of time. Here, we see an example of how swarm intelligence could emerge from simple micro-level behaviors. In the original ants model, we assume an ideal world that is flat without obstacles. And you might want to ask, what if the world is not ideal? Say, if those computational ants are in my room, will they be able to do the same? To answer this question, we adapted the ants model for NetLogo AR. So I am now standing in my lab, the place that has made NetLogo for the past decades. And I want to spawn a group of ants right here. The first thing I need to do is to scan the room, so that our model could get an idea of the physical space and align the computational world with it. The process usually takes a minute or two and currently depends on the latest iPad or iPhones. But once I finish scanning, I can keep using that data for other models or other devices as well. Now we get a rough understanding of the lab environment, as you could see from the 3D model. Once we click Finish here, the scan will be automatically mapped back to reality. Here we see the purple nest happens to be around me, and there are many ants scattered around. The blue pile of food is pretty close, so naturally, they focus on it first. But once the first pile is done, they are now in trouble finding more food. The cyan pile is on the other side of the table. But like the original model, eventually, one ant will find the pile. Then, they got stuck in the little corner. So now I decide to physically step in, as you can see my shoes here. I am represented in the model as an arrow, and I am now orange because I happened to step on the food pile. But I could not help them just with my body. So now I decide to change the block-based program to see if the ants could get out of the trouble. No, they did not, and that shows how the problem is more complicated than what I initially thought. Until now I was playing as an all-seeing ant. But it does not really correspond with how ants work. So I decided to put myself really in the position of an ant. As you can see now, I only have a very small range of vision. The purple arrow points to the direction of the nest, which ants also know because they can follow the smell of it. But I can no longer find the food pile without trial and error, and I have to follow other ants' chemicals to get some luck. The last thing we hope to show today is the abstract modality. As you can see, the abstract modality looks very similar to the classical ants model, with the exception that all obstacles are here in a top-down view. By clicking the AR button we can easily switch between the two modalities. And by easily switching between modalities, we hope that children could not only program AR experiences from laptops or Chromebooks, but also play with real-world inputs from different perspectives that could further support their thinking about complex systems.